July 1944. You are the driver of a 33-ton M4 Sherman tank, trapped in the suffocating labyrinth of the Normandy Bocage. Your commander orders you to breach the hedgerow directly ahead. You floor the accelerator. You hit the bank at 15 miles per hour. But you don't go through. You go up. The tracks claw at the ancient, compacted root system, and the nose of your tank pitches upward at a 30-degree angle. Suddenly, the laws of physics turn against you. Your hull machine gun is pointing uselessly at the sky. Your commander's periscope is staring at treetops. You are effectively blind, and in that moment of suspension, you have just committed suicide. The glacis plate in front of you is 2 inches of sloped steel, but the floor beneath your feet is barely 1 inch thick. 10 yards away, a German Panzerfaust team has been waiting for exactly this angle. They don't aim for the turret, they aim for the exposed, unarmored belly. One trigger pull later, the ammunition racks ignite. This is the vertical coffin, a tactical nightmare that has paralyzed the 1st United States Army for 6 weeks. To understand how a junkyard invention saved 1,500 men from this burning trap, we have to go back to the beaches. The invasion of Europe did not stop on the beaches. It drowned in the fields. When the Allied planners looked at aerial reconnaissance photos of Normandy in early 1944, they saw a patchwork quilt of lovely French farmland. They saw green squares bordered by shrubbery. They assumed that a 30-ton M4 Sherman tank, driven by a 400-horsepower Ford GAA V8 engine, would simply crush these bushes and roll into the open country beyond. They were wrong. The maps were lying. What the pilots saw from 10,000 feet as shrubbery was, in reality, the Bocage. This wasn't gardening. It was a military nightmare engineered by 5 centuries of French property law. Since the Roman era, Norman farmers had marked their land boundaries not with fences, but by piling fieldstones and digging ditches. Over hundreds of years, dirt accumulated on the stones. Oaks and elms grew out of the dirt, driving thick, knotted root systems down through the rock and soil, binding it all together into a geological concrete. By 1944, a single hedgerow was an earthen wall up to 10 feet high and 4 feet thick, topped by a dense canopy of tangled vegetation. And there wasn't just one, there were thousands. The terrain was a honeycomb of these box-like fields, some no larger than a football pitch. Every field was a fortress, and every hedgerow was a castle wall defended by the German army. The tactical reality for the American tanker was claustrophobic and lethal. The moment a Sherman tank tried to breach a hedgerow using brute force, the fatal geometry took over. The tank's tracks would grip the earth, but the wall wouldn't give. Instead, the tank would climb. The nose would rise into the air, exposing the thin underbelly armor on the floor of the tank to the enemy on the other side. Inside the tank, the sensation was sickening. The horizon would disappear, replaced by the sky. The hull gunner would be staring at clouds. The commander in the turret would be looking at tree branches. For 4 or 5 agonizing seconds, the tank hung there, belly up, a helpless metal whale beached on a wall of dirt. German defensive doctrine ruthlessly exploited this physics. They placed Panzerfaust team's infantrymen armed with disposable anti-tank-shaped charges directly behind the hedges. They didn't have to aim. They simply waited for the American tank to rear up like a show horse, then fired a hollow charge warhead into the thinly armored floor. The jet of molten copper would punch through the bottom of the tank, detonating fuel and ammunition instantly. The result was a massacre. In the first weeks of the campaign, First Army lost hundreds of tanks for gains measured in yards. Command was desperate. General Omar Bradley, the commander of the First Army, watched his grand strategy disintegrate. The plan relied on speed, a rapid breakout from the beachhead to seize the port of Cherbourg and swing south into the open plains of France. Instead, the greatest mechanized army in history was stalled in a traffic jam of its own making. Over 1 million men and thousands of vehicles were bottling up in a bridgehead that wasn't expanding deep enough to hold them. Engineers scrambled for solutions, but every standard method failed. They tried explosives. Engineer teams would crawl forward under fire, drill holes into the earthen embankment, and pack them with TNT. It worked, technically. The explosion would blow a gap in the hedge, but the blast was a dinner bell. It told every German mortar crew and artillery spotter within 5 miles exactly where the Americans were about to attack. By the time the dust settled and the tanks moved forward, the gap was already zeroed in by German guns. They tried the M4 dozer. This was a Sherman modified with a hydraulic bulldozer blade. It could plow through the earth without climbing, keeping the tank level and its guns on target. It was the perfect tool, except for the logistics. There simply weren't enough of them. A standard armored division might have hundreds of tanks, but only a handful of dozers. Worse, the hydraulic blade mechanism blocked the tank's own bow machine gun and added tons of weight to the front suspension. And the Germans, realizing the threat, prioritized the dozers above all else. If a column of Shermans appeared, the Germans killed the dozer first, sealing the rest of the unit inside the field. The frustration at the front lines was palpable. The infantry hated the tanks because they attracted fire. The tankers hated the infantry for not clearing the hedges. Morale began to bleed out along with the casualties. By mid-July 1944, the situation had curdled into a bloody stalemate near the city of Streetlow. The Allies were months behind schedule. Operation Cobra, the massive breakout offensive designed to shatter the German line, was on the drawing board, but it was a fantasy without a solution to the terrain. Bradley needed to move 3,000 tanks through the Bocage in a synchronized wave, but his army was incapable of crossing a single field without taking heavy losses. The mighty American war machine, capable of building a Liberty ship in 4 days and filling the sky with bombers, had been stopped cold by dirt and roots. They needed a miracle. They needed a way to cheat the physics of the climb. But the solution wouldn't come from the Pentagon, nor from the top brass engineers at Fort Knox. It would come from the mind of a 29-year-old sergeant who was looking at a pile of garbage and wondering if he could turn trash into a weapon. That solution came from the beaches, where Sergeant Curtis G. Cullen of the 102nd Cavalry Reconnaissance Squadron was staring at the wreckage of the Atlantic Wall. Cullen wasn't an engineer with a degree in physics. He was a cavalryman with a mechanic's eye for leverage. While the rest of the army saw the Bocage as a barrier, Cullen was looking at the debris littering the invasion sands, specifically the Czech hedgehogs. These were massive, sinister geometric shapes welded from 3 heavy steel beams. The Germans had planted thousands of them in the surf to rip the bottoms out of Allied landing craft. They were made of high-tensile industrial steel, designed to stop a tank or gut a ship. To the supply officers clearing the beaches, they were just dangerous trash that needed to be bulldozed into scrap piles. To Cullen, they looked like tusks. His insight was a masterpiece of nose-down mechanics. He realized the fatal flaw of the Sherman wasn't its engine or its tracks, it was its shape. The smooth, angled glacis plate on the front of the tank acted like a ski ramp. When it hit the dense earth of a hedgerow, the path of least resistance was always up. Cullen decided to change the geometry of the collision. He didn't need a saw to cut the brush. He needed a fulcrum to pin the tank to the ground. His design was bordering on heretical. He proposed taking the German beach obstacles, cutting them into jagged, 4-foot prongs, and welding them directly onto the final drive housing of the Sherman tank. It was a crude, violent modification that looked more like a medieval siege ram than modern military hardware. The physics of the Rhino, as it would come to be called, were totally distinct from the M4 dozer. The dozer tried to push the earth away. The Rhino used the earth against itself. When a Cullen-equipped tank rammed a hedgerow at 15 miles per hour, the steel tusks would strike the base of the wall first, inches above the ground. Because the prongs were angled downward, the impact didn't push the tank up. It drove the teeth deeper into the tangled root system. This created a locking moment. The prongs anchored the tank's nose into the base of the hedge. As the 400-horsepower engine continued to drive the tracks forward, the tank couldn't climb because it was physically pinned to the wall by its own tusks. The kinetic energy had nowhere to go but forward. The tank would shear through the base of the earthen wall, ripping the roots apart and collapsing the structure from the bottom up. It was the difference between trying to drive a car over a locked door and simply kicking the hinges off. Cullen grabbed a welding torch and scavenged a hedgehog from the scrap pile. He ignored the standard operating procedures that frowned upon welding random steel to the hull of a combat vehicle. With the help of his maintenance crew, they cut the heavy German beams into shape and fused them to the front of a light tank for a test run. The crew revved the engine and charged a hedgerow that had stopped them cold for weeks. They braced for the familiar, sickening lurch of the climb. It never came. The tank hit the wall with a sound like a train wreck. The earth shook, roots snapped with the volume of pistol shots, and dust exploded into the air. But the tank stayed flat. The gunner kept his sights level. The vehicle tore straight through the ancient berm. emerging on the other side with its belly protected and its machine guns sweeping the field. Behind them, the hedgerow wasn't just crossed, it was shattered. A gaping hole remained in the wall, wide enough for infantry and support vehicles to follow. Cullen had found the key to the prison. He had turned the enemy's defense into the instrument of their destruction. But proving it worked on one tank in a test field was one thing. The invasion of Europe was running on a strict timetable, and Cullen was about to find out that the only thing harder than cutting through a hedgerow was cutting through the United States Army bureaucracy. Bureaucracy did not kill the idea. It weaponized it with terrifying speed. When General Omar Bradley saw Cullen's prototype shatter a hedgerow on July 14th, he didn't ask for a committee review or a safety study. He looked at his watch. Operation Cobra, the massive breakout offensive designed to end the stalemate, was scheduled to launch on July 25th. Bradley turned to the commander of the 52nd Ordnance Group and issued an order that defied industrial logic. He wanted the Cullen cutter installed on every single tank in the First Army. The math was impossible. The First Army had over 3,000 tanks. The deadline was 11 days away. This wasn't a manufacturing challenge. It was a logistical hallucination. They needed to modify 250 tanks every 24 hours in the middle of a war zone, with no factory, no blueprints, and no raw materials. Ordnance teams immediately descended on the invasion beaches like locusts. They were ordered to strip the sands of the very obstacles that had killed so many of their brothers on D-Day. The Czech hedgehogs, once the symbols of Nazi tyranny, were dragged out of the surf by recovery vehicles and hauled inland to makeshift open-air factories set up in muddy apple orchards. But as soon as the first cutting torches hissed to life, the operation slammed into a wall of metallurgy. The engineers discovered that the Germans hadn't built their beach defenses out of standard construction iron. To rip the hulls open of landing craft, the Germans had used high-tensile industrial steel, likely salvaged from railway infrastructure or heavy fortification stocks. It was dense, rich in carbon and manganese, and chemically engineered to resist deformation. When the American welders applied their standard oxyacetylene torches to the beams, the steel fought back. It didn't cut cleanly. It resisted the thermal lance. The metal absorbed the heat so intensely that the copper tips of the cutting torches began to glow cherry red and then melt, clogging the nozzles and effectively destroying the tools. Work ground to a halt. The field depots were littered with burnt-out torches and half-cut beams. The timeline for Operation Cobra was ticking down, and the junkyard architect looked like he had built a solution that couldn't be mass-produced. The 52nd Ordnance Group didn't have time to requisition heavier industrial cutters from the States. They had to hack the chemistry. The welders realized that the only way to cut the German steel without destroying their own equipment was to manage the thermodynamics manually. They organized into cooling rotations. A welder would blast the German beam for exactly 2 minutes, then immediately douse his torch tip in a bucket of water, while a second welder stepped in to continue the cut. It was a bucket brigade of fire and steam. The orchards filled with the hiss of quenching metal and the blinding blue-white flash of arc welding. They worked in 24-hour shifts. At night, under strict blackout conditions to avoid attracting German bombers, the welders worked under heavy tarps that turned the air inside into a suffocating oven of ozone and sweating bodies. The scope of the effort was biblical. From the beaches of Omaha and Utah, a river of scrap steel flowed inland, was cut into jagged teeth, and welded onto the final drive housings of the gathering armored divisions. The Rhino modification added nearly 300 pounds to the front of the Sherman, shifting its center of gravity and compressing the front suspension springs by inches. Drivers worried the extra weight would bog them down in the mud or snap the final drives. Ordnance officers told them to shut up and drive. By July 24th, the orchards were empty of steel and full of monsters. The 52nd Ordnance Group, through sheer brute force and sleep deprivation, had managed to modify over 60% of the First Army's armor. The result was a Frankenstein fleet. Some tanks bore the clean, sharp tusks of Cullen's original design. Others, when the hedgehog steel ran out, were fitted with crude green dozers made from heavy railroad ties or surplus bridge girders. They looked primitive, absurd, and terrifying. As the tanks moved into their assembly areas for the morning of the attack, they resembled prehistoric beasts, their steel teeth caked in mud, waiting for the signal to feed. General Bradley had his 3,000 tanks. But as the sun set on July 24th, A terrifying question circulated among the crews. They had tested the device on a few hedgerows in a safe rear area. They had never tested it against a live enemy who was shooting back. The device solved the physics of the climb, but it created a new vulnerability. To use the Rhino, a tank had to accelerate to 15 miles per hour, fast for a tank in rough terrain, and slam violently into a solid wall. If the welds failed, the prongs would snap, and the tank would vault upward into the vertical coffin. If the prongs held but the wall was reinforced with hidden concrete, the impact could concuss the crew or throw a track, leaving them immobilized in the kill zone. Cullen had given them a key, but to turn it, every driver in the First Army had to commit to a high-speed collision with a fortified wall, trusting their lives to a weld made by an exhausted mechanic in a dark field. The deadline arrived at dawn. The sky over Street Low turned gray, then orange, as the heavy bombers arrived to open the door for Operation Cobra. The waiting was over. The metallurgical nightmare was finished. The combat test was about to begin. It began with the sound of the world ending. At 9:38 hours on July 25th, the ground shook with a violence that registered on seismographs in England. Over 1,500 American heavy bombers, B-17 seconds and B-24 seconds, carpeted the narrow strip of the street, low front, with 4,000 tons of high explosives. The carpet was designed to stun the elite German Panzer Lehr division, but as the dust clouds drifted over the cratered moonscape, the German survivors shook off the concussion and manned their positions. They were battered, but they were professional. They knew the drill. They knew that when the American tanks appeared, the Bocage would fight for them. A German Obergefreiter with a Panzerfaust huddled in a foxhole behind a 12-foot hedgerow, listening to the squeal of approaching tracks. He wasn't panicked. He had his firing solution memorized. Wait for the engine noise to peak, watch the nose of the Sherman rise over the berm, and fire into the exposed floor plate. It was a trap that had worked for 40 days. But the tank that burst out of the smoke was not the prey he expected. It was a Sherman from the 2nd Armored Division, hell on wheels. And it wasn't slowing down to crawl over the obstacle. It was accelerating. Inside the tank, the driver gripped the steering levers, his foot mashing the throttle to the floor. The speedometer climbed 10, 12, 15 miles per hour. The crew braced for the impact. Instinct screamed at them that this was suicide, that hitting a solid earth wall at combat speed would shatter the transmission or knock them unconscious. Then, the Rhino struck. There was no climb. There was no nose-up vulnerability. The 4 steel tusks, salvaged from the beaches of Utah, slammed into the base of the hedgerow with the force of a freight train. The impact didn't push the tank up. It transferred the vehicle's 33 tons of kinetic energy directly into the root system. For the German gunner on the other side, the world simply dissolved. One moment he was staring at a solid earthen rampart. The next, the wall exploded inward. A cloud of dirt, ancient roots, and field stones erupted into his fighting position. Through the choking dust came the Sherman, not belly up and helpless, but dead level, its tracks churning the earth, its bow machine gun already firing. The fatal geometry had been inverted. Because the tank remained flat, the Panzerfaust operator had no target. He was staring at the thickest armor on the vehicle, the sloping glacis plate, and the muzzle of a 75mm cannon that was pointing straight at his chest. The engagement lasted seconds. The tank crushed the foxhole and roared into the field beyond. But the true brilliance of the Rhino wasn't just that the tank survived, it was that it brought friends. In the previous weeks, a tank that breached a hedge was a lonely metal coffin. It would crest the wall, land on the other side, and be immediately swarmed by enemy infantry because the American riflemen couldn't scramble over the barrier fast enough to protect it. The Rhino changed the tactical symphony. By ripping a 12-foot gap through the base of the wall, the Cullen device created an instant doorway. As the Sherman punched through, an entire squad of infantry from the 22nd Infantry Regiment sprinted through the breach right behind it, using the tank's armored bulk as a moving shield. This was the combined arms doctrine finally realized in the dirt. The tank suppressed the heavy machine guns. The infantry hunted the anti-tank teams, and the artillery walked a curtain of steel ahead of them both. The German defensive network, engineered to hold static lines, disintegrated into chaos. Reports flooded into the German 7th Army headquarters, frantic and nonsensical. Field commanders shouted over the radio that American tanks were suddenly everywhere behind the hedges, flanking the bunkers, racing across open pastures. The German doctrine relied on the terrain slowing the enemy down, buying time for their superior Tiger and Panther tanks to maneuver. But the Rhino had erased the terrain advantage. A field that used to take an hour to secure was now being crossed in 14 seconds. The breakthrough was exponential. One Rhino tank would breach a wall, fire into the corners of the next field, and signal the advance. A second Rhino would rush through the gap and hit the next hedgerow without pausing. The American advance, previously measured in yards per day, jumped to miles per hour. By noon, the paralysis of the last 6 weeks was gone. The 2nd Armored Division wasn't just pushing the line, they were dissolving it. They drove so fast that German officers were captured while sitting down to lunch, their command posts overrun before they could burn their maps. General Fritz Bayerlein, commander of the Panzer Lehr Division, watched his elite unit evaporate. He later described the attack as a conveyor belt of armor. He had prepared his men to fight a conventional war, to fight tanks that behaved like tanks. He hadn't prepared them to fight machines that ignored geography, monsters that ate the very fortifications designed to stop them. In the chaos of the breakout, the 4% failure rate that the ordnance officers had feared did manifest. Some prongs snapped, some tanks hit hidden stone walls and threw their tracks. But in the grand calculus of the offensive, it didn't matter. For every tank that broke down, 50 more punched through, their welded teeth covered in French soil, driving deep into the German rear. By sunset on July 25th, the impossible stalemate was broken. The road to the south was open. The junkyard invention had worked, and the Allied army was finally doing what it was built to do: run. They didn't just run, they hunted. The breakout from Street Low transformed the entire character of the war in Western Europe overnight. For 6 weeks, the conflict had been a grinding, First World War-style attrition battle, measured in yards. But as the Rhinos tore down the fences, the speedometer of the invasion redlined. The Germans, masters of the blitzkrieg, suddenly found themselves on the receiving end of their own invention, engineered in reverse by a sergeant from New Jersey. The German tactical doctrine for retreat was disciplined and geometric. When a defensive line broke, the Wehrmacht units were trained to fall back to the next natural barrier, establish a new perimeter, and bleed the enemy again. In Normandy, that meant retreating to the next hedgerow. But that logic relied on the Americans being road-bound. It assumed the Shermans would have to funnel through the few open gates or drive down the narrow sunken lanes where anti-tank guns were waiting. The Cullen cutter destroyed that assumption. The German infantry would sprint back to a new defensive hedge, breathless and terrified, only to find that the green monsters, as they began calling the pronged Shermans, were already there waiting for them. The American tanks weren't using the roads. They were cutting straight lines across the map, traversing the fields as easily as open plains, flanking every ambush the Germans tried to set. General George Patton, whose Third Army was activated on August 1st to exploit the breach, poured his armored divisions through the gap the Rhinos had opened. The result was not a battle, but a pursuit. The chaos funneled the German 7th Army into a catastrophic kill box known as the Falaise Pocket. As the Americans swung south and east, and the British and Canadians pushed from the north, nearly 100,000 German soldiers and thousands of vehicles were squeezed into a shrinking corridor of death. Here, the strategic value of the trash welded to the tanks became undeniable. The roads inside the pocket were gridlocked with burning German transport, horse-drawn artillery, and panicked staff cars, all pounded incessantly by Allied fighter bombers like the P-47 Thunderbolt and the RAF Typhoon. The only way for the German panzers to escape was to go cross-country, to use the Bocage to hide from the aircraft and slip the noose. But the Rhinos owned the Bocage now. American armored columns, sporting their jagged steel teeth, pushed into the flanks of the retreating German mass. They cut off the escape routes through the fields, compressing the pocket tighter and tighter. A tank commander from the 3rd Armored Division later recalled watching a German Panther tank try to maneuver through a heavy hedge to escape an airstrike, only to belly up and stall. The American Sherman next to it, equipped with a Cullen cutter, simply drove through the adjacent wall and put a 75mm armor-piercing shell into the Panther's flank. The terrain, once the Germans' greatest ally, had become their prison. By August 21st, the pocket was sealed. The destruction was absolute. Pilots flying over the area reported that the stench of decaying horses and burning fuel could be smelled at 2,000 feet. The German 7th Army effectively ceased to exist as a fighting force. 50,000 Germans were captured, 10,000 lay dead in the roads and fields. The equipment losses were staggering. Over 500 tanks and assault guns were left rusting in the Norman countryside. The junkyard architect had done more than solve a local tactical problem. He had enabled the destruction of an entire army group. As the dust settled and the Allied armies raced toward Paris and the Seine, the vindication of Sergeant Curtis Cullen was absolute, though largely unspoken in the High Command's official communiques. The impossible logistical hurdle of welding scrap metal to 3,000 tanks in 11 days had paid a dividend that military statisticians struggled to quantify. The competitor's narrative focused on the 4% failure rate of the prongs, treating it as a dramatic failing. In the cold light of the aftermath, that statistic was laughable. The Rhinos had breached tens of thousands of hedgerows. They had saved an estimated 1,500 tank crewmen from the vertical coffin men who would have otherwise burned to death while their tanks pointed at the sky. But the math went deeper. If the breakthrough had been delayed by another month, the autumn rains would have turned the unpaved roads of France into swamps, bogging down the Allied advance and giving Hitler time to stabilize the front. The Cullen cutter bought the Allies the most precious commodity in war: time. It bought the summer. General Bradley, notoriously reserved with praise, wrote in his memoirs that the device was absurdly simple, yet acknowledged it was the key that unlocked the invasion. He personally ensured Cullen received the Legion of Merit, a rare honor for an enlisted man, typically reserved for high-ranking officers planning grand strategy. Yet, as the front line moved east, leaving the broken hedgerows of Normandy behind, a strange thing began to happen to the Rhinos. The terrain changed. The armies entered the open plains of central France, where speed on the road was more important than breaching power in the field. The heavy steel prongs, which had been the difference between life and death weeks earlier, were now just dead weight, dragging down the tank's fuel economy and stressing the suspension. Crews began to cut them off. In assembly areas from Chartres to the Belgian border, the tusks that had broken the Wehrmacht were torched off and discarded in ditches, left to rust alongside the very enemy wreckage they had helped create. The specific tool was being discarded, but the revolution it sparked, the idea that a soldier in the field could outthink the engineers in the lab, was about to face a new threat: the erasure of history. The Rhino was disappearing. The war was moving on, and the man who invented the device was about to fade into the gray anonymity of civilian life, his contribution buried under the ticker-tape parades of generals who never held a welding torch. For 20 years, the man who saved the First Army lived in total obscurity. Curtis Cullen returned to Cranford, New Jersey, took a job at a liquor distribution company, and simply went on with his life. There were no parades for the junkyard architect. The Rhino tanks themselves were mostly stripped of their tusks as the war moved into Germany, the steel melted down or abandoned in French ditches. To the casual observer, it seemed like the invention had served its momentary purpose and then vanished, much like the sergeant himself. But while the physical steel was gone, the intellectual shockwave Cullen caused had permanently cracked the foundation of military doctrine. The real legacy of the hedgerow cutter wasn't the device itself. It was the institutional realization that the solution to a billion-dollar problem might not come from a laboratory in Detroit, but from a mechanic in the mud. This was the birth of field-expedient warfare as a formalized American doctrine. Before Normandy, the U.S. Army was rigid, running on manuals written in peacetime. After Cullen, the command structure began to actively solicit the ingenuity of the enlisted man. The concept was codified in field manuals, like FM 5-31, instructing officers to look for local materials to solve tactical blockages. When American troops faced the concrete bunkers of the Siegfried Line, or later the jungle fortifications of Vietnam, the spirit of the Rhino lived on. It evolved directly into the hillbilly armor of the Iraq War scrap metal welded to Humvees by desperate soldiers who knew, just like Cullen, that the official equipment wasn't enough. This creates a stark contrast in military philosophy that defined the mid-23th century. The German approach was to over-engineer solutions, building heavier, more complex Tiger tanks that required specialized rail cars and factory maintenance. The Soviet approach was brute force if a hedgerow is in the way. Flatten the entire grid square with artillery until the map changes. The American approach, crystallized by Cullen, was the 80% solution right now. It accepted that a crude weld made in a muddy orchard was superior to a perfect blueprint that arrived 3 weeks too late. And what of the failure rate that critics and historians sometimes fixate on? The narrative often highlights the 4% failure rate of the prongs tanks, where the weld snapped or the tusks bent as a source of dramatic tension. implying that 92 crews were betrayed by the device. This misses the forest for the burning trees. In the grim calculus of high-intensity warfare, a 4% mechanical failure rate is a statistical miracle compared to the 100% lethality rate of exposing a tank's belly to a Panzerfaust. The 92 failures are a footnote. The 1,500 survivors are the headline. Yet, Cullen remained a footnote himself until a summer evening in 1964. The United States was looking back at the 20th anniversary of D-Day. The former Supreme Allied Commander, Dwight D. Eisenhower, was walking through the Normandy fields with CBS newsman Walter Cronkite for a televised special. They stopped in front of a surviving hedgerow, ancient and overgrown. The cameras were rolling. Cronkite asked the general how on earth the army had broken through these earthen fortresses. Eisenhower didn't talk about his brilliant general staff. He didn't talk about air power. He looked at the camera and told the story of a sergeant from New Jersey. He named Cullen, he explained the tusks. And in living rooms across America, the soldier's scientist was finally given his due, not as a quirky anecdote, but as the man who handed the keys of France to the Allied armies. Cullen had died just months before the broadcast, never knowing that the president would validate his work to millions. But the validation was already carved into the history of the U.S. Army. He proved that in a democracy, the chain of command is not a chain on the mind. He proved that rank does not equal intelligence, and that sometimes the most advanced weapon in the arsenal is a pile of scrap metal and the courage to use it. That courage is preserved today in cold steel, sitting quietly in the halls of the General George Patton Museum at Fort Knox. There, mounted on the bow of an M4 Sherman, you can still see the rusted remains of a Cullen hedgerow cutter. To the uninitiated tourist, those jagged metal teeth look like an afterthought, a rough modification that ruins the sleek lines of the machine. They walk past it, drawn to the massive 88mm gun of a German King Tiger or the high-tech optics of a modern Abrams. But you now know the truth. You know that those crude triangular prongs are the only reason the Allied armies broke out of Normandy. They represent the difference between a tank that climbs into its own grave and a tank that crushes the wall. They stand as a physical testament to the fatal geometry that almost lost the war and the simple leverage that won it. The story of the Rhino is the ultimate rebuttal to the idea that wars are decided solely by who has the biggest gun or the thickest armor. In July 1944, the Germans had better tanks. The Panther and the Tiger were engineering marvels, superior to the Sherman in almost every metric of firepower and protection. But they were defeated by a piece of beach trash, welded to a final drive housing. The Germans lost because they trusted the map. The Americans won because they were willing to rewrite it with a welding torch. Curtis Cullen's legacy is 1,500 men who came home to raise families instead of burning to death in a French field. It is a legacy that proves that when the doctrine fails and the manual is wrong, the soldier who looks at a problem and says, "I can fix this," is the most dangerous weapon on the battlefield. But Sergeant Cullen wasn't the only mad scientist of the Second World War, and the hedgerows weren't the only obstacle that required a bizarre mechanical solution. While Cullen was scavenging steel in Normandy, a British major general was already operating a secret zoo of armored monsters that defied sanity. He was building tanks that could swim in the ocean, tanks that whipped minefields with steel chains, and tanks that could jump over concrete walls. They called them Hobart's funnies. And they are the reason the D-Day beaches weren't a total massacre. If you want to see how the British Army turned the tank into a swimming, flailing, flame-throwing circus of destruction, make sure you are subscribed. We are going to open the classified files on the 79th Armored Division in our next briefing. If this deep dive into the physics of the breakout gave you a new appreciation for the Sherman tank, hit that like button. It helps us get these for